All right, let's start us off with some chapter 10, trigonometric identities. So chapter 9, we set our time doing some unit circle, right triangle trigonometry. Chapter 10 is going to be more abstract. I don't know if that's really the word I want to use, but I will tell you these next couple of sections. So these are all the first three sections here, 10, 1, 2, and 3, are all just going to be identities and plugging into formulas. That's the abstract part. Now, using these formulas, we are going to do rewriting them, working them over. It's called proving trig identities if we're looking back through this. When we do that, the whole concept behind these trig identities and working this out is literally not because it's something that you're going to be using all of the time. It's more a process of how to think. All right. So right now, when we're doing these trig identities and working this through and proving these and rewriting this stuff, it's more along the lines of, let's work you over. How can you problem solve? So that's what's happening. All right. So right now, we're going to throw some more identities, make sure we have our identities down. I already gave you a bunch, making sure you're good with that. And then we're just going to keep working with them. All right. Cool. So let's rock the socks off this thing. Reciprocal identities, which you already know. So these are ones that we already know. So I'm just going to write them out easy style. So I know that tangent of theta is equal to 1 over cotangent of theta, which then you automatically know that cotangent is equal to 1 over tangent. I'm just not going to write all of these out. Cosine of theta is equal to 1 over secant, and sine of theta is equal to 1 over cosecant. So you automatically know that you can swap these and it's still those identities. All right. Quotient identities. You have tangent is equal to sine over cosine. And cotangent, notice up here, if I have tangent and cotangent are reciprocals of each other, so if tangent is sine over cosine, then the reciprocal of that is cosine over sine. So it's more than just this relationship with reciprocals also affects this, right? And affects everything that we're doing. You can just interchange any of that. So any identities that you know, you can work with those identities and manipulate them algebraically in order to pull it off. That's the beauty of these identities. Pythagorean. Pythagorean identities, I'm going to have sine squared plus cosine squared equals 1. Then we have 1 plus tangent squared is equal to secant squared. And then cotangent squared, or 1 plus cotangent squared, is equal to cosecant squared. All right. So the most common one is sine and cosine, and you saw that with some of your homework, but you also have tangent and cosecant and cotangent. Tangent secant buddies, cotangent cosecant are buddies. All right. Now here's new. Those are ones that you already know, and we're digging on those. Let's say this. These up here, you need to, if you haven't already, you need to memorize those. All right. So if you haven't already memorized and figured all that stuff out, you need to get that done. These new ones, these even and odd identities that we're getting ready to look at right here, you don't have to memorize that. All right. You don't have to have these memorized. You can always look these up later, any of that kind of stuff. Now, when we, yes, I forgot an I. When we were graphing sine and cosine, right? And everything bounces off sine and cosine, so we've got that. So when we're graphing these sine and cosine functions, remember that your sine function starts at 0 and then works its way over, right? Your cosine starts up here at 1 and goes down and then goes on, etc. Whoops, that's kind of janky, isn't it? But it starts up here at 1. So the reason why I'm bringing this up is because if I have symmetry about the y-axis and I'm folding it on itself, then I know that is an even function. If I have symmetry about the origin, so this is y-axis symmetry. If I have symmetry about the origin, what do you know about that? Odd. Let's scoot this down so they're lined up correctly. All right, so if you're symmetric about the origin, then that is your odd function. If it's symmetric about the y-axis, that is your even function. Okay, so with that piece of information, if I'm going to input, so remember way back when we were doing our algebra and we were talking about odd and even functions, if you input a negative for an odd function, you output a negative. The input and the output are both negative, right? You input that x, you output that y. So if you output a negative, the whole thing is odd. That was our test. For an even, if I input a negative and my output is original, then I know that's even. So we're making that connection right now. If I input a negative angle measurement, then my output is also negative. And we know sine and cosecant are best friends. So they behave the same. Oops, I almost put sine there. Power of suggestion. All right, the same thing is happening here if I'm talking about cosine. If I input a negative, then my output is positive because it's even. Same thing with secant, because it bounces off of it, right? Because those are even. These are odd. Now what we haven't talked about yet is tangent and cotangent. Now keep in mind our tangent and our cotangent, what do I say? When I'm still talking about sine over cosine and I have tangent, tangent is still, I'm sitting there on my center and I can spin that around, so it is also odd and symmetric about that origin. Cotangent is that reciprocal, so we know that it's going to behave the same way. So if I input a negative angle, then I output a negative function. If I input a negative angle for cotangent, I'm also outputting that negative function. These are also odd. Now, again, I want to reiterate, you are not going to have to memorize those. How to do that and work that, I don't expect you to memorize those. This is how you're going to see it in your homework. Super easy kind of stuff. Oh, doggone, I was hoping to put an example right on there. Here, I'm going to stick it over here, shove it on this side. No, I'm not. I'll just do it up here. So here is from the homework 10.1.7. They don't even have any examples in the book. If I have a cosine of negative 4.38, cosine is even. If I have a negative input for cosine, I know my output is positive. Literally, that's it. If I have sine, so here's another one. What if I have the sine of negative pi over, I don't know, 17 or something that we can't figure out easily? This is negative sine of pi over 17. Right? That's it. Negative input, your whole thing ends up being a negative for the output. That's literally it. Cotangent, tangent, secant, cosecant, all that stuff just behaves the same. That's the big deal when it comes to odd and even. So the moral of the